Here we have definition of dot product. We define the dot product or scalar product between two formula A vectors, formula B, and A dot B formula S. One can prove that the dot product is commutative, distributive over addition, and associative with respect to scalar multiplication. That is the formula. A geometric interpretation of the dot product is also possible. Given any two vectors A and B, place the vectors tail to tail and impose the coordinate system with origin at the tail, such as that A is a parallel to the x-axis and B lies in the xy plane. As shown in the figure, the angle between the two vectors is denoted as theta. Then in this coordinate system, A equal to modulus AI, B equal to modulus B cos theta I plus modulus B sin theta J, and A dot B equal to modulus AB cos theta. A result independent of the choice of coordinate system. If A and B are parallel, then theta equal to 0, and A dot B equal to modulus AB. And in particular, A dot A equals to modulus A2. If A and B are perpendicular, then theta equal to pi over 2 and A dot B equal to 0. Here is example question and answer. 1. Using the definition of the dot product A dot B equals to A1 B1 plus A2 B2 and plus A3 B3. Prove that A dot B equal to B dot A dot B equals to A1 B1 plus A2 B2 plus A3 B3 equals to B1 A1 plus B2 A2 and plus B3 A3 equals to B dot A. Next we have B, A dot bracket B plus C bracket, and A dot B plus A dot C, and there is the answer. And next we have C, the question and the answer. And then we have a definition of cross product. A geometric interpretation of the cross product is also possible. Given two vectors A and B with angle theta between them, impose a coordinate system so that A is a parallel to the x-axis and B lies in the xy plane. Then A equals to modulus I, B equals to modulus B cos theta I plus modulus B sin theta J, and A dot B equals to modulus AB sin theta K. The coordinate independent relationship is where theta lies between 0 and 118 degrees. Furthermore, the vector A times B points in the direction perpendicular to the plane formed by A and B, and its sign is determined by the right-hand rule. Also observe that modulus A times B is the area of the parallelogram whose adjacent sides are the vectors A and B. Here we have a definition of cross product. We define the cross product or vector product between two formula A vectors and formula B as a formula A times B. Defining the cross product by a determinant serve to remember the formula. One can prove that the cross product is anti-commutative, distributive over addition, and associative with respect to scalar multiplication. That is the formula. So here the example question and answer. Let C equals A minus B. Calculate the dot product of C with itself and thus derive the law of cosinus. Firstly, consider the triangle composite of three vectors pictured below. With C equals A minus B, we have that formula where theta is the angle between vectors A and B. In the usual notation, if A, B, and C are the length of the side of a triangle and theta is the angle opposite side C, then C2 equals to A2 plus B2 minus 2AB cos theta. This is the conclusion. A scalar is a physical quantity with a magnitude only. A vector is a physical quantity with magnitude and direction. Vectors may be represented as arrows where the length of the arrow indicates the magnitude and the arrowhead indicates the direction of the vector.